In this video, we are going to look at how to calculate percentage yield, and not only to make use of this calculation formula, but to also see another variation of how this question can come about. In this question, we are looking at 12.4 grams of copper carbonate in a crucible after heating, produces 7.0 grams of copper oxide. The question asks you to calculate the percentage yield and then determine the mass of copper 2 carbonate needed to produce 15 grams of copper oxide. Now let's break this question into two parts. The question actually has two parts. First, the question wants us to calculate the percentage yield. That's the first part. Then with this percentage yield, with this value, they want us to determine the amount, the mass, of copper 2 carbonate needed if instead of 7.0 grams, I want, 15.0 grams. Now, let's recall, the formula of percentage yield is actual yield, which is the actual amount obtained from a reaction, divided by a theoretical yield, which is what the reaction should give you if everything goes well. And take this value times 100 to give you the percentage yield. Now, the question, has already given us the actual yield. Now, this actual yield here has already been given, It is none other than your 7.0 gram. So all that is left for us is to calculate the theoretical yield. Now, I've written over here, the MR of copper oxide as well as the MR of my copper carbonate. Now, in order to get a theoretical yield, we first need the equation. So this is how you write the equation. Copper 2 carbonate is a formula of CuCO3, solid. Upon heating, the question tells us that it produces copper 2 oxide. Now, as you can see, in order for this equation to be balanced, we still need to produce something that contains a C and an O. And in this case here, being a carbonate, I think it will be very likely that this is actually CO2 gas. And if we were to look at this equation, this is balanced already. Now, in order to calculate the theoretical yield, all we need to do is to calculate the mass that you're supposed to get, if everything goes well. Now, the question has already given us this value over here, 12.4 grams of copper carbonate. Now, in order for us to calculate the mass of my copper oxide that is supposed to obtain, first, we recall that this is actually 1:1. So, the mass, of my CuO to be obtained is actually first found by taking the moles of my copper carbonate, in this case here by taking 12.4 grams dividing by the MR of my copper carbonate, which is 124. Now this is the moles, moles of my CuO that should be obtained because in this case, 1 mole of copper carbonate gives you 1 mole of copper oxide. Now, to get the mass, we will actually take moles times MR. In this case, the MR, because we want to find the mass of CuO, the MR is actually 80. So that, students, will actually give you a value of 8.0 grams. And this, student, is actually your theoretical yield. So the first part of the question wants us to calculate percentage yield, which means that if you apply this formula here, the percentage yield is equals to the actual yield being 7.0 divided by 8.0 times 100. And that will give you a value of 87.5%. And that, student, is your answer for a percentage yield. Now that we got this value for percentage yield, we will then be able to work on the next part of the question. Now, the percentage yield, okay, is actually, I'm going to write down here, 87.5%. Okay, this is the percentage yield. This means, right, for every 100 grams of CuO that can actually be produced, okay, I will, because of the percentage yield, actually only obtain 87.5 grams. Now, the question wants us to find, okay, how can I produce 15 grams of copper 2 oxide? Now, this means, right, in order for me to get 15.0 grams of copper oxide, okay, this 15.0 grams, right, is actually, okay, representative of, okay, 87.5%. Okay, because what happened is for a certain amount of copper oxide that you obtain, 87.5% of it will give us 15.0 grams. So what is then the 100%? Okay, 100%, right, will correspond to 15.0 divided by 87.5 times 100. And if you press the calculator, right, that would actually give you 17.1 grams. So what this means is that in order for me to get, okay, to get 15.0 grams, okay, of copper oxide, okay, I actually need to produce 17.1 grams of my copper oxide. Okay, I actually need to produce 17.1 grams of copper oxide so that 87.5% of this yield will give me 15 grams of copper oxide. Then in this case here, student, the question is how much, okay, okay, copper carbonate, okay, how much copper carbonate do I actually need in order for me to produce 17.1 grams of copper oxide? So all this, okay, brings us back to our stoichiometry using our mole equation. So which means, right, the mass of my CuCO3 is equals first to the moles, okay, 17.1 grams divided by the moles of MR of CuO, 80, okay. This is the moles, okay, of CuCO3 I need because it's 1. Take this value here, okay, I will multiply it by, because it's carbonate, okay, 1, 2, 4. And that, student, will give me the final value of 26.6 grams. Okay, which means that by using 26.6 grams of copper carbonate, I will be able to obtain, okay, assuming everything goes well, 17.1 grams of copper oxide. And because, however, the percentage yield is 87.5%, this means that out of this 17.1 grams of copper oxide, okay, I will then only be able to retrieve 15.0 grams. And this, student, is how you can solve this type of question. Thank you.